and this is Changing the Narrative. I'm your host, David Rives, and we are changing the narrative every week on this podcast. We've been spoon-fed a narrative of naturalism, a narrative of atheism, a narrative that says that, hey, you don't mean anything. You're just an accident of the cosmos. You're star stuff. Well, I want you to know that you are special, that you are fearfully and wonderfully made, and that God has a purpose for your life. You know, every week on the program, we talk to someone who is changing the narrative in their particular field. But today, we have Dr. Randy Guliuzza from ICR, the Institute for Creation Research, back on the program. Welcome to the program.
Thank you. Thank you much for the invitation.
I'm telling you what, I love what you do. I love talking with you about these kind of things because it's common sense principles that anyone can understand, but it radically changes your view on this narrative that we've been fed of Darwinian evolution, a narrative that says that, everything happens through mutations, natural selection over millions of years to just gradually improve a creature until pretty soon you don't recognize that creature. It's an entirely different creature. And then over millions of years, it continues to improve this creature again until you don't recognize the creature. Now, it's an entirely different animal, right? And eventually, that leads to humankind being the result of random mutations, of chemical accidents, of natural selection over hundreds of thousands of years. Tell me a little bit about how you've been combating this, and then we're going to do a deep dive into that.
Right. Your introduction is so good because you tie in the fact that Darwin changed the narrative about how creatures came about and how they got their diversity of life. But you are also explaining at the same time how they attained their perfection, how they attained the fact that they looked like they were highly engineered, because you said they got better and better over time, and then eventually they become so specialized to a particular niche that they begin to diversify. So in reality, Darwin is explaining the perfection of creatures, and as a secondary effect, he explains their diversity. In other words, how they split off over everything. But fundamentally, he's also saying, and you brought this in, and it's so powerful in your introduction, that we're without purpose, that it was a purposeless process. Mm-hmm. And the purposelessness, you're pointing out to people that we are not this purposeless thing that's out here just existing on a pale blue dot. You're saying that we are meaningful, that we are special, that we were created, what you're really saying is in the image of God, and every person is special on all of those areas. And Darwin, he's not going to recognize that, but the whole idea of purposelessness was not in that social way where we're thinking we're a purposeless thing.
Sure.
He's saying purposeless, meaning there was no engineering, there was no planning, there was no foresight behind it. He's attacking the developmental part that is a purposeless process,
while still admitting that there appears to have there appears to be these design patterns, right?
Exactly.
Everybody loves cherry picking or quote mining the eye couldn't have come about by random processes. Charles Darwin did say that, but then he spent the next entire chapter, if not the next chapter and a half, explaining that even though it appears that it could have never come about by natural processes, somehow it did.
Exactly. It's because it's so irrational to think that eye, with all of its intricacies, could have happened by a purposeless process without foresight of what you even want the eye to do. Mm-hmm. There's a purpose to the eye. It gathers data. Yeah. It's this massive sensor.
Yes.
And that is gathering all of this data that's in. So the whole idea of purpose is anathema, because purpose and engineering go hand in hand. Ooh. As engineers always design with a purpose, and the purpose for what you're constructing always constrains your design. Okay. So purpose and engineering go hand in hand. So he is going to push back against purpose in everything, even though through a blind process that gets honed and refined over really eons in their view, it takes on the appearance of having a purpose, and it takes on the appearance of having been designed. So that's how they get around it.
Okay, you said a moment ago, purpose and engineering go hand in hand, but engineering and design put constraints on things. So then a scientist would look at something and it would say, well, this could be better. Better for what, right? In its current design, it has the flexibility to do exactly what it needs to do. Is that what you're saying?
Yes. That's a great question, because you even bring a little distinction between the difference between design and engineering. Engineering, in many ways, says this could be better, because you and I, we could design something, but is it going to work? Is it going to hold up? Is it going to withstand? Engineering is the idea where we test it. We bring in physics. We run something through rigors, and we say, oh, making this gas turbine out of wood will not work. You must make it out of steel. And then you have to have this type of steel. And then you have to have these kind of bearings. And the bearings need to be made out of this kind of material. Engineering is what brings the reality, the buildability to design. And engineering is what says this can be better. It's the whole testing process.
I love it. Okay, Dr. Guliuzza, tell me a little bit about, number one, your background, number two, your passions, and number three, how it led you to where you are today.
Well, my background, I initially was an engineer.
Okay.
I'm a medical doctor.
Okay.
But I was initially an engineer. In fact, before I was even an engineer, I graduated with a degree in theology from Moody Bible Institute.
Wow.
I started as an engineering student, and then I felt the Lord was leading me into the ministry, both my wife and I. So we transferred from an engineering school, went to Moody Bible Institute in the late 70s, early 80s. At Moody, believe it or not, I found an issue of Acts and Facts, our starship, our flagship magazine for ICR that we have, that changed my life. I contacted the founder of ICR. He recommended that I finish my engineering education, and I did. So I practiced as an engineer for a decade. His colleague, Dr. Dwayne Gish, recommended that I get a doctorate and learn biology. That led me to medical school. And after a long process, I eventually became on staff with ICR, and after a longer process, I became the president of ICR. But right now, what we're really working on is to bring about a theory of biological design to show that organisms really look engineered because they are engineered.
Okay.
And I probably shouldn't say show, because it's more of a hypothesis. Scientifically, it's more of a hypothesis. I hypothesize that the reason why birds look engineered to fly is because they were engineered to fly. So I hypothesize this. Therefore, if birds were engineered to fly, what should I expect? What predictions would I have if they were, in fact, engineered that way?
So the narrative has been set, and it hasn't really been challenged. There's been a theory of biological evolution for a very long time now. But robust science means multiple working models. It means having theories. It means having hypotheses, trying to test all of that out. And the tests, there hasn't been any competition for the evolutionary theory. So this new theory of biological design is, for the first time in a very long time, something that you can make predictions on. Is that correct?
Exactly.
Okay.
And we need to challenge Darwinian evolution. And we talked about that on another podcast, which we have to do. But we can't just point all of the weaknesses with that explanation. What we really need to do is replace it, and replace it with one that has better explanation. So if I hypothesize that the reason why a bird looks like it's engineered to fly is because it was engineered to fly, I would then predict I would predict that as we begin to reverse engineer the bird, which is what biology fundamentally is, we take things apart piece by piece, very methodically, study those elements, study how they fit into systems, study how they work together. That's what reverse engineering is, and that's what biology fundamentally is reverse engineering. I would predict that as we reverse engineer bird flight, for instance, that I would find engineering principles at work.
Okay.
I would find features on a bird, for instance, that I would find on a human-engineered aircraft, which might increase efficiency. I would find features on a bird which may reduce noise.
Right.
I would find these features, and I would find that they would operate by the exact same way. So I can make these predictions that I would find them. And not only can biology inform engineering, but engineering can inform biology to help direct how I will do my research.
Yes. Yeah. Okay. So that's interesting because it's almost blurring the lines there. But it reminds me of biomimicry in a way, in that with biomimicry, you're looking at biological systems and saying, how can we benefit by trying to copy that? But then reverse engineering biology is saying, well, how do we look at these biological features and figure out how they work? And then you're asking the question, well, does that appear to have these engineering features built in?
Exactly. Biomimicry is how engineering benefits from biology.
Okay.
We look at something in biology and, oh, that really works cool, so we copy it.
Yeah.
We copy it. We never give the creator, the original creator, the credit for it. We kind of steal those. We kind of steal those ideas, but we copy it. But we haven't been thinking the other way around. So let's say we find something in biology that we don't know how it works. We're going to tackle it for the first time to determine what it is. Well, we could be able to look at something that human engineers have already engineered that performs a similar function, and then I would predict, okay, here's something I don't know in biology, but I do know how this human engineered thing works. Therefore, I predict in my research, I should be able to find A, B, and C in this biological thing. Therefore, I'm going to start a research program which is going to look for A, B, and C because I'm anticipating that I should find them. In other words, I predict that I should find corresponding features between human engineered things and biological things performing the same function.
Wow.
And guess what? We find them.
We find them. The more that you start looking, the more you find them. But nobody thought to look. That's the problem. I mean, that's an overarching term. Nobody. But what I mean is we've been so stuck on this idea of Darwinian evolution for so long that scientists have been somewhat blinded to any other explanation or to any other way of looking at things. And this is opening up new research that could catapult science in the next 15 years farther than it has gone in a long time. Because even though technology is increasing at a rapid pace, science, the groundbreaking scientific discoveries of the past several hundred years were made by those who started with biblical foundations and said, well, if the Bible is true, then we should expect to see design features. If the Bible is true, then we should expect to see this, right? Making predictions that actually started with biblical principles. Can you give me an example of something that you're currently looking into, or something that you've started to notice these patterns in?
Sure. Let's take biological adaptation.
Okay.
I mean, adaptation is the name of the game in creation evolution. If organisms couldn't change, then a theory of evolution could never get going.
Right.
I mean, you have to be able to change in order to evolve by his theory. So whoever is explaining how adaptation works is really controlling the narrative and really can change the narrative. So Darwin changed the narrative by explaining adaptation. And when you said nobody was looking, that's not totally wrong. So when an organism changes, it was basically seen in the past as this. The environment changes, and then organisms over a period of time, they've changed to match that environment.
Okay.
So there was this temporal thing where the environment changes and then organisms change. Darwin's view basically sees the environment as driving the bus, the environment as running the show, the environment as driving adaptation, because the environment changes and then organism changed. But there's a part where nobody bothered to look. And there was a time when nobody could really look into the organisms at the molecular level, but nobody was looking. But I'm going to say that explanation is completely backwards.
Okay.
The environment is not driving adaptation. When you take the time to look in the creatures, you find that they're actually driving their own adaptation. Sure, the environment changes, but how in the world does that drive the change? What we need to do is look between the exposure and the response.
Okay.
There's something between that exposure, the environmental exposure, and the organism's response, and what's in between that is where all of the engineering is. And the engineering is filled with things like sensors that can sense what's happening in the environment. And then I would look inside and think, well, that's data. Data has to be sent inward. There must be a data transmission feature in there. I look and I find it. Then there has to be a data processing system in there which can process the data that says, if I detect these things, then I want to respond in certain ways. There should be logic in there.
Wow.
I find the logic. There should be a way to affect that response. There should be an output mechanism. So between the exposure and response is where all the engineering lies, the sensors, the logic, the output responses that were in the organisms all along that enable these organisms to change as necessary and that are really driving the show, so that exposures are really just variables. They're either there or they're not. And organisms determine how they are going to respond very purposefully based on all the engineering, now that we look, between the exposure and the response.
In other words, I love the way you're putting it when you talk about sensors, because you take a security camera, for example, right? It's basically a glorified sensor that senses something.
That's what it is.
And yet, if it senses the lights coming on and off, I don't want to call the police if the lights go on and off, even after hours, right?
Right.
Okay, so the sensor has to have a code built into it that says, when the lights go on and off, don't call the police. But if you detect motion after hours, after that sensor has been turned on, and that motion is large and it's moving across the screen in such a way that it could be someone in there that's not supposed to be in there, then that is when the code says, okay, analyze this, and when this takes place, this is the response that you should take. You should call the police, you should notify the owner, you should do that. Well, that was built inside of that whole program, wasn't it?
Exactly. And that is such a great example because it's demonstrating these levels of logic. It's this if-then. If there is this light or whatever it is, and then there's another code that says, and if there is this type of motion, then call the police. So what you find in this system is the logic expressed of the engineer who designed it, and creatures do the exact same thing. Creatures have those exact same sensors that say, if you detect this, then do that. So on one of our programs, we discussed how you cooperate with the bugs in your gut.
Yes.
And so...
Give us another example.
So they're exchanging materials back and forth with each other constantly. And so, this is quite remarkable. Sometimes cells within the gut will even put a piece of DNA or RNA into the lumen, and if a microbe detects it, then it will bring it in itself. This is quite remarkable. It will process it, and then it will put a product back into the lumen of the gut, and if the cells of the lumen detect that product, then they will absorb it and bring it in. And so we see the sensors, we see the logic, but we see two separate entities working together in a highly programmed way where they're exchanging materials and information that way.
Now, this has happened within like computer programming for years, but where this actually interfaces with our listening audience, right, is this push for home automation, right? It's the ITTT, the if this, then that, right?
Right.
Where you can say, okay, well, if at this time of day you detect that my owner is in the home, then I want you to play this through the speakers to give them some ambient music for right? In other words, you can stack on these things one on top of the other, on top of the other, on top of the other, but that is just now getting into the general public's consumption or even their knowledge, and yet it's working every single day and has been within biological mechanisms for thousands of years.
Exactly. And therefore, if organisms look engineered because they are engineered, then I would predict to find these stacked systems on top of them, one after the other, and that's exactly what I find. In fact, we could do a whole show on anticipatory systems, where organisms are not just responding reactively to environmental changes, they respond proactively. This is incredible. So organisms detect changes in an environment now, but these stacked systems that we're just talking about that we would expect to find enable the organism to respond in advance to something that it will find. So one study on bees that were as larvae in the honeycomb, they were starved. During development, they were reprogrammed to be more resistant to starvation in the future because it is a proactive response to that.
Really?
And it's not just bees. There was a study on tomato plants that were never attacked by a slug or eaten, but other plants were. It could detect that, and in an anticipatory response, it was already producing chemicals inside the tomato plant, making it resistant to be attacked in anticipation of things. So we find this if-then logic, not just at a base level, but as you've already mentioned, stacked one on top of the other.
On top of the other. I just got back from leading 40 people on a creation photo safari to South Africa, and one of the things that we saw out in the bushveld over 11 days, some of the most incredible night skies you can imagine, some of the most beautiful wildlife. But then you see all of this and you only think of like animals when you think of Africa. No, the plants are just as amazingly designed. And there were these trees, and the trees would actually connect roots, one tree to the other, so that if this tree all the way down there across the other side of the bushveld began to like all the vegetation was eaten off of it by giraffes in the area or whatever, it's like, well, we somehow have to protect ourselves in some way. So this tree, through the root system, lets all of the other trees down the line all the way to the other side of the bushveld know. And all of a sudden, the trees on the other side of the bushveld, where the giraffe is just about to walk to, begins to put off this unpleasant thing that keeps the giraffe from eating all of the leaves off of it, right?
Exactly.
I mean, it's when you think of these examples and then you think of the design and the thought that must have gone into that, how does this just happen by chance?
It doesn't happen by chance, and it doesn't happen by magic. And that's where engineering, a theory of biological design, comes in. So I don't know whether anybody has exactly researched how this tree communicates with all the other trees, but if you and I were to design a communication system between two separate entities, one tree to another tree, we would have to design into that communication system certain specific elements that must be there. They must be there in order for this to happen.
Okay.
You have to have the sensor. You have to have a way to communicate. You have to have a communication system on that. since I know these trees are not communicating by magic,
Yeah.
in spite of all the favored and selective abilities that Darwin projects onto nature, I know in advance, if I were the research person on these trees, I could make a list from an engineering perspective. I anticipate finding this,
Yes.
and this, and this, and this, and then I would go looking for those things. And I guarantee you we're going to find them because it's not operating by magic.
Right.
It will operate by these basic principles.
It's time, and I want to encourage everybody listening, ICR.org, Dr. Randy Guliuzza, check out continuous environmental tracking. Check out some of these other groundbreaking things that you're currently researching. But it's time we get the pseudoscience out of science.
Right.
Because it's been there far too long. It's time we change the narrative and start saying, well, let's look deep into these things. Let's expect to find something and then say, does it have it? Right? And if it does, if we're expecting things, if we're predicting things, and all of a sudden we start to find those components, and those components point back to engineering perspectives, then it means that this is pointing to an idea that engineering requires an engineer, that design requires a grand designer. And who is that designer? Well, if the Bible is true, and if the Bible is what it says it is, divinely inspired, the Word of God, then we know we can stand on that. We know that there is someone who is not only outside of the universe, who is not only the creator of all things, but also inside the universe, able to talk with us, to have a relationship with us, in the form of Jesus Christ, who wants us to be a part of his family for eternity. And that is an exciting thing, and that's what we should be looking forward to and what we should be absolutely thrilled to see, because everything is pointing us in this direction. Dr. Guliuzza, thank you so much for being a part of the program today. I would love to have you back about 10 or 15 more times.
Oh, I'd love to it.
And thank you for joining us today on Changing the Narrative. I'm David Rives. And until our next time, I want you to keep looking up, because truly, the heavens declare the glory of God. Find us on all social platforms to stay informed. Watch Genesis Science Network 24/7 for free on Roku, Fire TV, and on our website. Visit the world's largest origins-based store, creationsuperstore.com. Plan your trip to the Wonders Center and Science Museum just outside of Nashville, Tennessee. Donate to our nonprofit ministry to help us continue sharing truth.